Like fractions, that means the bottom is the same. So if you want to add, for example, 7 over 12 plus 2 over 12. Since the bottom is the same, we leave it alone. We don't add them. That's a common mistake. People want to add the two numbers on the bottom. You don't touch them. You add the two numbers on the top. If the bottom is the same. Yep. If it's not the same, it's a different story. We'll get to that shortly. What's 7 plus 2? 9 over what? 12. Now, you can do all this work and you're happy and you put your answer and you go to correct it, they go, you got it wrong. Why? You need to simplify your answer. Even if it doesn't say simplify, you have to simplify your answer. 9 and 12, you can divide them by what? Bless you. By 3 is 3. By 3, this is what? 4, which is what? 3/4. And if you want to see that, if you want to see what's going on here, if you take a box, you go, let's see. These are slices of cake. It was somebody's birthday. And you came in, and there were 7 out of these 12 pieces here. 7 of the 12 were missing. We gave them to people. So this is gone. 2, 3, 4, 5, 6, 7. So you come in, 7 of these 12 pieces are missing. You go, I'm hungry. You grab 2 pieces now. You add that and that. What did you eat? What's left now? Or what's missing? Notice each one of these is a fourth of the cake, right? 1, 2, 3/4 of the cake is missing. 9 out of 12 pieces is gone, which is when you break it down just to longer strips there, that's 3 of the 4 pieces are missing. So if the bottom is the same, just leave the bottom alone. If it's addition, add. If it's subtraction, subtract. 7 over 15 plus 3 over 15. Are these like fractions? Yes, the bottom is the same. 7 plus 3, which is what? 10 over 15. Can we simplify that? Oh, 15. By 5. You can divide both numbers by 5. By 5, this is what? 2. Bless you. By 5, this is what? 3. And what's the answer? 2/3. Let's try this one. 13 over 40 plus 11 over 40 plus 23 over 40. The bottom is the same. 13 plus 11 plus 23. Let's add them. What's 13 plus 11? 24, right? 24 plus 23 is what? 47? And if you want to change that to a mixed number, that looks like what? 1 is it 7 over 40? Because if you divide 47 by 40, that's 1. 1 times 40 is 40, and the remainder is 7. 1 and 7, 40.
Wait, I'm sorry. Can you do the last part again? I was too busy copying.
This one?
Yeah, where you added them up and you got 47 over 40.
Yep.
How did you simplify? Or what did you do to simplify?
Divide them. 1 times 40 is 40. What's the remainder? 7. 1 and 7 over 40. One and 7 over 40. Let's try subtractions. (19 over 20) minus 11 over 20. Again, adding and subtracting. If the bottom is the same, leave it alone. 19 minus 11. What do we have? 8? And I think I can divide the 8 and the 20 by 4, right? By 4, this is 2. By 4, this is 5. It's 2/5. (11/7) minus 3/7. The bottom is the same. 11 minus 3, which is what? 8/7. Again, if they want it as a mixed number, you go 8 divided by 7. 1. 1 times 7 is 7. What's the remainder? 1. That's the 1. That's this one. And 1/7.
So some of them you can just eyeball them and just kind of like already tell like it's just going to be 1 and
Sure.
1/7.
Yep. Like a number like this.
Is that ever
Just
safe, or do you
yeah, that's fine. Think of it like you have a box that will hold 6, 7 containers, and you get 8 of them. So one of them is going to be full, and the other one is going to be 1 out of the 7 slots. Okay, where this becomes a problem, I'll go to the next page, is when you are trying to adding or subtracting. We'll call this unlike fractions. That means the bottoms are different. That's where the challenge. When the bottom is different. So let's take an example. I want to add 1/10 plus 2/15. Notice the bottom is not the same. So you're not going to add 1 plus 2/10 plus 15. Doesn't work that way. We need to find a common denominator, just like we did before. And the way we find the common denominator, we take the two numbers on the bottom, the 10 and the 15, and we do prime factorizations. 10 is what? 2 times 5, right? Both are prime numbers, so it's 2 times 5. The 15, 3 times 5, both prime numbers, 1, 3, 1, 5. So the LCD is going to be what? The multiplication of all the different factors. I see a 2, I see a 3, I see a 5. Each raised to its highest power. The highest power of 2 is 1. The highest power of 3 is 1. The highest power of 5 is 1. Remember, with the LCD or LCM, we do not combine the power here. We look at each one individually. The highest power is 1. 2 times 3, 6 times 5, that's what? 30. So my LCD is going to be 30 now. You'll have to multiply the 10 by what to make it 30? 3. 3 times 1? 3. You're going to multiply the 15 by what to make it 30? 2. That's 4. Now this, just like the previous section, adding like terms. Now the fractions in the bottom have the same number. So the top will be 3 plus 4, which is what? 7/30. Let's try another one. 11 over 12 plus 3 over 4. Now you said early, sometimes I can look at them and get the answer quickly. Well, in this case, the LCD, my goal is to make the two numbers on the bottom the same. And I don't have to make the tree to get the LCD. I can make the two numbers on the bottom the same if I change this number to what? 12. So, yep, exactly. So you don't have to make the tree all the time. Sometimes just by looking at it, wait a minute, if I multiply this by 3, I'm going to have a 12. So you'll have what? 11 over 12 plus what? Is that 9 over 12? Yes.
Do you always have to multiply to be the same?
To get them the same. You can't add and subtract. Multiply or divide. So since the bottom is the same, that's 12. What's left? 11 plus 9. Is that 21? And again, they probably don't like that answer. What's 21 divided by 12? 1. 1 times 12 is 12. What's the remainder? Is that a 9?
Yeah.
Here, you got to be careful now. Notice, I could have simplified this. I just didn't see it till now. 1 and 9 over 12. Well, you can simplify the 9 over 12. What's the 9 over 12 if you simplify it? 3 over what? 4. So the answer is really 1 and 3 over 4. I just forgot to simplify it here. Notice, I could have simplified it here. I just missed it. Yes?
It's 11 plus 9 is 20.
11 plus 9, it is 20. I knew that. So 20. So that will leave me with what? 8. 8. Now you're telling me. Okay. So by 4, I can divide by 4, which is what? What's 8 by 4? 2. What's 12 by 4? Is that 3? 1 and 2/3. Let me squeeze one more. One third minus 2 over 9 plus 7 over 8. That I got to think about the LCD. I can't really guess. Well, I could. I kind of know what the answer to it. But most of the time, you don't know the answer to that. So the 3 happens to be a prime number. So I don't have to break it anymore. The 9 is what? 3 times 3. That's 3 squared. The 8 is what? 2 times 4. 2 is a prime number, 4 is not. 2 times 2. That's 2 to the 3rd. My LCD is the multiplication of all the different factors. Well, I only see 2 and 3 for factors on the bottom. And what is the highest power of 2? 3. And what's the highest power of 3? 2. 2 to the 3rd, that's 8. 3 squared, that's 9. 8 times 9 is what? 72. Almost done. 3 goes into 72 how many times? I think 24 times. So if you multiply this by 24, if you're not sure how many times, just divide them. Go 72 divided by 3. It will give you the 24. So 24 times 1 is 24. 72 divided by 9, that should be an 8, right? So 9 times 8 is 72. What's 2 times 8? 16. 8. 72 divided by 8 is 9. 9 times 7, 63. It's 24 minus 16 plus 63. What's 24 minus 16? 8. 8 plus 63? 71 over 72. And I don't think you can simplify that, and that's your answer. We're not done with this section.